Okay, class, this is going to be a little video about Lab 10, and the title of it is Solubility. And after you've worked through the pre-lab calculations and worksheet, you'll be doing there are actually two parts to the lab. The first one is called qualitative measurement of solubility, and then the second half is called quantitative. The second half I will demonstrate for you, so you will not have to do that part, and we will talk about that in class. So you will use the data that you see in this video for the second half, the quantitative, and then I will show you the basics for the first part, which is the qualitative measurement of solubility, which you'll recognize when you read the lab. So for this qualitative measurement of solubility, this is the equipment that you will need. Of course, you will need your safety glasses and your gloves. And then you will also need your test tubes and 5 of the chemicals that come in your kit that are listed here. So you'll need your calcium hydroxide, cupric sulfate, sodium carbonate, potassium bitartrate, and also some sodium borate, along with some tap water and your test tube rack with test tubes. And like I said, the other part, the quantitative, is something I will demonstrate with the burner, so you won't have to worry about that. So that's basically all you need for now, and we'll show you how to do this first part. Okay, class, so for this first part, the qualitative measurement, what you're going to do is set up your test tube rack with some test tubes, and I only had 4 test tubes. We actually need 5, so I've found this little glass container that I'm going to use for my 5th test tube. If you don't have a 5th one, then you can just reuse one of the 4 that you have. But what you're going to do, and I've numbered the test tubes 1 through 5 for the 5 solids that we're going to measure in terms of solubility. And then you're going to fill the test tubes about 2/3 full with just regular tap water. You can just fill it right to the bottom of the label. And so you'll fill all 5 just with regular tap water. And then we're going to take and add each of the solids to the test tube and shake them to observe solubility. So this part is strictly observation, and you'll make notes in your lab document as to what you saw when you added the solids. And so the first one that we're going to test is our calcium hydroxide, and it says use half of a spoonful. So we'll take, this is very powdery, so we'll take half of a spoonful of the calcium hydroxide, and we'll add it to the first test tube. You might want to hold this, let's hold this over the sink just in case we want to spill it. This is very powdery, so let me get something to put underneath in case we spill the powder. Not making too much of a mess. Okay, so let's add calcium hydroxide to this now. I'm going to use the flat end instead of the round end, that might be easier. Okay, so add a little bit of calcium hydroxide to the test tube, and then with our gloves on, we're going to hold our thumb over the top, we're going to invert, and we're going to shake. And then we're going to make our observations in terms of solubility for the calcium hydroxide. This is what the calcium hydroxide test tube looks like after first shaking it. And then we're going to let it sit for a few minutes and record our observations over time for each of these. Okay, so that's the calcium hydroxide. So let it sit for several minutes and then shake it again and make some more observations. So this is going to take a little bit of time. Next one is going to be the copper sulfate. So we'll take our spatula, and remember we're working with copper sulfate before, and we know that its solubility is already limited, just based on the experiments we've done in the past with this. So take some small chunks if you can find them, about half a spoonful, and we'll add that to number 2 test tube. Just like that. And then we'll put our thumb over the top again. Make sure you wipe your thumb off so you're not putting any calcium hydroxide in there. And then we're just gonna shake it vigorously, and we're gonna record our observations. So that's number 2 with copper sulfate. And make your observations, and you can see, as we expected, it's starting to change color a little bit as it slowly dissolves. Then a third one is going to be sodium carbonate. That'll be number 3. So we'll take a little bit of calcium carbonate in our spoon here, and we'll add it to the test tube. And then we'll put our thumb over the top again, and we'll flip it around, and we'll shake it. And this is what the calcium carbonate looks like for me right at the moment. Now we'll let it sit for a few minutes. That's number 3. Number 4 is the potassium bitartrate. This looks like a very powdery solid as well, so let's take our flat end of the spoon. It'll be easier to put in the test tube. And we'll add a little bit, about half of a spoonful of the potassium bitartrate. Cover up with our thumb again, upside down, shake, upside down, just to mix it to see their solubility. And you can see how that was looking. So you make your observations on your own for your test tubes. Then the last one is the sodium borate. So we'll take, if you have a 5th test tube, that's great, or you might have to wait and get another one that's available. We're going to add a little bit of the sodium tetraborate to a few mils of water. And I'll just hold my whole hand over it, and I'll shake it upside down like this, just to kind of mix it. You actually use your stirring rod too. And we'll see what the looks like initially. The tetraborate. And then we're going to let those sit for a few minutes, make our initial observations, and then after about 5 or 10 minutes, let's say wait 10 minutes, then come back and make some other observations after they've had a chance to sit for a few minutes. And then you'll kind of rank or notice how soluble each of these salts are in water. Okay? And so then you make your observations, and we'll go from there. So don't forget to do your pre-lab, read lab, do the pre-lab calculations, and then do this qualitative measurement for the various salts. We'll talk about solubility when we go over the lab in class. So that's the qualitative step 1 after the pre-lab. Okay, class, so you have let the test tube sit for 10 minutes, and you've shaken them periodically throughout that time, just to help with the solubility and the dissolving of the solids. And now you want to compare. You're going to rank these as salts as either very soluble, slightly soluble, or insoluble. And I'm just going to show you what mine look like. So this is number 1. This is the calcium hydroxide, and note how the colony is on the upper layer, and you still have solid on the bottom. So that probably is not very soluble. Number 2 is our copper sulfate, and we remember this from other experiments. We still have solid on the bottom, but notice the blue color at the top. So that's probably slightly soluble, for example. And then number 3, where we have almost a totally clear liquid. And this was our sodium carbonate. So you rank that in terms of solubility. And then this is number 4. This is our potassium bitartrate. Cloudy at the top with solid at the bottom. And then our sodium tetraborate. So give this at least 5 or 10 minutes. No, give it at least 10 minutes for the solubility to occur within the test tubes, shaking them occasionally, and then make your final observations at the end as to how soluble each of these salts are compared to each other. Okay? Okay, class, so I'm going to demonstrate the quantitative measurement of solubility. And what we're going to do is prepare a saturated solution of sodium chloride or just table salt. By saturated, I mean we've added enough sodium chloride salt solid to a given amount of liquid so that it no longer dissolves and it actually will stay as a solid in solution. So to begin with, we're going to take 50 mils of water and we're going to add it to a beaker, and then we're going to add salt to the beaker. So let me get 50 mils of water. Okay, class, so I've got 50 mils of water in my graduated stone. I'm going to add it to the beaker. And then I'm going to start adding salt to the beaker. And we're going to keep adding it. Wait about 15 minutes to be sure that there's still solid in the beaker after we've dissolved as much as possible. So let's just start adding salt until it no longer dissolves. Let's keep stirring that. We're just going to keep adding salt until it no longer dissolves to our 50 mils of water. The procedure says to use 100 mils of water. I'm just going to use 50 because eventually we're going to evaporate off the water from the salt and weigh that. And it'll take too much time to evaporate that much water off. So we're going to dissolve make a saturated solution of sodium chloride in water. After we know that all the precipitate is as much as dissolved as possible in that amount of water. Okay, so we'll let that stir and let that sit for a few minutes, and we'll come right back. Okay, class, so I prepared a saturated solution. I can tell it's saturated because there's solid sodium chloride in the bottom. It's no longer dissolving, no matter how much I add to the water. We also want to record the temperature because solubility is very much related to the temperature. And so I have a temperature here of about, let's see, must be pretty cold temp water. So I've got about, let's see, 15, 16, 17, 18.0 degrees C. I'm going to record that as my temperature, so be sure you jot that down. 18 degrees. And now we need to filter the undissolved salt from the dissolved salt in the water. And I have a Buchner funnel with a filter paper set up, and we're going to pour the saturated solution into the filter so they end up with just the saturated solution in the bottom. Okay, so this may take a few minutes, and I'll have to come back after it's filtered through because sometimes the filtration takes a while. We don't want to overrun the filter paper. Okay, so we're going to let that filter, and then we'll be back for the last step. Okay, class, we're just about done filtering. collected now about, I don't know, 40 or 50 mils of filtrate of the saturated solution of sodium chloride in tap water. And to begin with, we measure, we're going to add this liquid to a beaker that's been pre-weighed. So my beaker I just weighed is at 4.1 grams, so I've recorded that in my lab notes. And now that we've filtered this, we're going to take a known weight of our solution and we're going to add it to the beaker. So let's just call that good. And we've got 4.1. Now we're going to add this to the beaker. We're going to record the total weight of the beaker plus the solution. Add that. And we have a total weight of 5.6 grams. 5.6 grams. So that means that the weight of the solution is 1.5 grams of the solution. Now what we're going to do is heat this beaker until all the water is evaporated, and we're going to weigh the amount of solid salt that's left over. And to do that, we're going to use our little alcohol burner, which I've got set up here and ready to go. So I'm going to light it. Get it going. And then we're just going to heat the beakers gently. You don't want to heat it too quickly, because otherwise it'll boil over and bump. So we got that going nicely now, and we're going to add our beaker on top, and we're just going to heat it gently until all the water has evaporated and boiled off. And we can see that it's warming up a little bit. We do have our flame going. And so we'll let that boil gently, and then we'll weigh the beaker, let it cool, and weigh the beaker after the water has evaporated. Okay, we'll be back. Okay, class, so I've got the beaker on the burner and we're heating this up so the water to evaporate. And I want to call your attention to a mistake that I gave you in terms of the numbers. I inadvertently had set my scale for measuring ounces instead of grams. So the numbers that you should have for the empty beaker is 116 grams. The mass of the beaker plus solution is 161 grams. That gives you a mass of the solution as 45.1 grams. So be sure you make those corrections, because we want to do things in grams and not ounces. And then we'll make sure we have the right units going forward. So just FYI. Okay, class, so I think you can see now that we've heated this beaker. It's starting to boil a little bit, so the water is starting to evaporate. And once it gets down, all the water is gone. We don't want to heat an empty beaker. We don't want the beaker to break. So then we'll just give this a few more minutes and we'll let the beaker cool after the water is gone, and we'll get our weight of salt that's left with the beaker. Okay, class, now we can see as the water is evaporating, there's less and less water in the beaker. There's less and less water to dissolve the salt that's there. We're actually seeing solid salt coming out of solution being deposited on the sides of the beaker as the amount of water decreases, and so there's less water to dissolve the amount of salt that's there to begin from the beginning. So getting down to about halfway of the water has been removed, and then we're going to cool it and weigh it and see how much salt we have left over, and that'll give us the solubility in grams per milliliter of sodium chloride in water. Class, you can see now that we're getting close to the end. There's actually no clear water left. It's maybe about 10 mils of water left, and the salt is still remaining behind while the water is being driven off. And we'll give this a couple more minutes. But I just wanted you to be able to see the water vapor coming off and how cloudy the solution is becoming as the salt remains behind. And we break it up with a stirring rod every now and then just to help break up the chunks of salt that are there, so the water can come off more easily. Okay, class, you can see I've turned off the burner now, and we see that our beaker is still hot, but I'm gonna let it dry. See, all that's left now is the solid salt. We're gonna let that cool and completely dry, and then we'll reweigh and see how much salt we have left and how much salt we're able to get into that amount of water. Okay, class, we're going to take our final weigh here. You can see all the water has been driven off in our beaker, and I can see that one source of error might be being able to drive off all the water in this salt using just the burner without having to have it splatter all over. But this looks pretty dry, so we're going to go ahead and take our measurement and see what we get. It's cool now, and it looks fairly dry. And we can compare our number to what the theoretical value is for the solubility of salt in water. And maybe we'll let it set. Maybe we'll measure it twice. I'm going to get the final weight twice after we've let it dry out, maybe overnight. So we'll see. Okay, so let's get our final weight here. And we have for our beaker plus salt, our solute is 131 grams, which makes sense since our beaker plus the solution was 161 grams. So that means the mass of the salt is going to be beaker solution minus beaker plus ice is going to be 161 minus 131, which would be 30 grams. So the mass is going to be 30 grams, and that means the mass of the solvent or water will be 15, since the mass of the solution total was 45. So the solubility of the salt is going to be 30 grams over 15 grams of water. It actually wants it in terms of 100 grams of water, so we'll have to do that calculation. So let's see. So obviously water is going to be very high, so I have my calculator, we'll figure that out. But so final numbers are 30 grams of solute in 15 grams of water. That's our initial data.